So last time we understood that the naive Bayes classifier uses the following criteria for deciding which group this is. So it takes the probability of being spam under some conditions, D, and then divide it by probability of not being a spam under some conditions, D, right? Actually, the way I think I coded it was I put non-spam on top. It doesn't matter, really. So, now here, by D, I mean this is like appearance of words. We are going to use words that appear in the spam email or non-spam email, whatever the email is, there's a text in there, right? And then the words will appear, let's say, send me $1 million, okay? So that's like the 4 words that you see. Then these words are going to count for something, okay? And then we're going to determine that, okay? So in the Bayesian theorem, what we do is we have, if I want the probability of something not happening, then the probability is computed by first multiplying this by, you switch this around, right? That's Bayesian idea, right? You switch the condition and the actual event around so that this one, when you switch them around, this is what's called the likelihood. So this is called probability, this is called likelihood because you're thinking of these x1 through xn as some kind of a parameter. Okay, and then you have to divide this by something. I can't, it should be probability of x1 something. But as the fine point of the naive Bayes was that we don't care about this thing in the denominator, right? So this is what we're going to compute in the code that we're going to write. And furthermore, the naive part, this being naive, means that although these are not independent events, you just treat them like independent events and assume that the probability goes like that. Okay? This is not. Okay, so that's what's going to replace the top. And the bottom will be replaced by the one without s, right? And then, now you do know the log rules. Hopefully you remember the log rules. What can you do if you have division inside?
Subtraction.
Yeah, you can just log of p not sd minus log of p sd. And by the way, what we're doing is not going to matter which log you choose. You could choose log base 10 or log base e or log base any number is fine. But just because in Python the default is that when you have np.log it's log base e. So that's what's going to be actually computed. It's not that important. Okay, and then if you stick this in there, think about what happens. Log of p not s, x1 through xn, is going to be log of p of this thing. Yeah, I don't want to write it again, but this goes in here. But then if you have a multiplication inside log, what do we know? You can add them, right? So what happens is that it's not as plus log p x1 not s plus da 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 plus log p xn not s. And that's the way we're going to compute this. Yes?
Can we only use log base 10 or can we also use the maximum?
That's why I said you can use log base anything. Log base 2, anything is okay. Okay. Now, the reason that you take logs is because these computer systems are very stupid, so that it doesn't know the difference between 10 to the negative 1,000 versus 0. So if you ask Python what is 10 to the negative 1,000, it'll just say 0, although that's not true. Whereas if you take log, this becomes a number that's doable. Right? The thing is, when you compute this just using this, and if the email is very long, and these words are something that don't appear a lot, you end up with a very, very small number. And there's a risk of that number being a number that's registered as too small for Python to actually do anything. Okay? So that's why we're using the logs. And that's why instead of multiplying first and computing the logs, we're calculating the log of each number and then adding. Okay? By doing that, you can avoid the problem with the way that all computer languages treat these decimals. Okay? Yes?
So is that why log was invented?
Log was first invented by John Napier, I think 16th century, to do a huge computation. When you have like scientific notation and the numbers come out with 10 to some power, which happens in astronomy. And if they were to actually write down the digits and multiply, it's just untractable. It's just too much, especially back then people had to write in hands. So what he did was he realized, well, you just need certain accuracy. So let the powers of 10 be taken care of and multiplication done separately, and then he realized, oh, there's a whole new way of doing math where you convert everything to some 10 to some powers, and he made the table. That's how it started. Yeah. So yeah, when you have like numbers that are too big or too small, too close to 0, and you have to do something with it, a good idea is to take logs. Right? Okay, so that's what's going to happen. All right, so it sounds like a plan, but then there's something, and this part I kind of explained last time, but there's something that I didn't tell you last time, which is how do you actually figure this out? So how do you calculate P1 not S? Well, let's first think about the meaning of this. What does this mean? X1 is a word, right? So it's the probability of X1 appearing in, this is not, so it's non-spam email. That's what it is, okay? So if you open an email that's not a spam, right? And you see the word hi, and now you want to know the probability that the word hi would appear if you just opened a random ham. You know, non-spam is also known as ham, right? Okay. You open a ham email and you just point to a random word. What's the probability that that word will actually be hi? Well, it's very low, but it does have some non-zero probability, right? So the way you are going to compute it is just count all the number of occurrences of x1, right? Divided by number of words, total words in ham. That's what we're going to do. Okay? And when we do this, we're not thinking of infinitely many emails that's going around the world. We're just taking a part of the email data that we have that's a training set. Okay, so again, we're going to take a portion, say 80% of our data as a training set, and then in each of the ham emails, we're going to count all the occurrence of x1, okay? And then also count total number of words in the ham emails and divide that, that's going to be a probability. But wait, this has some kind of danger. See, you need to have probability, to have a fair comparison for both, you need to have P of x1 for spam and P of x1 for non-spam, even if the word only appears in one of the cases, okay? So maybe in your training data set, for some reason, technology only appeared in the non-spam one, and none of the spam emails had the word technology. Now that's going to cause a problem because then you have a probability of 0 for the spam ones, and you're just saying that no matter what it is, the moment you see the word technology, this is going to come out as 0, because 0 times anything is 0. But is that fair? No, that's not good, because, you know, sometimes maybe in the test set that you have, one of the spam mails may have that word training, technology. And then it's going to be completely messed up, because you're trained to say, oh, whenever you see the word technology, it's not a spam. And that just is a very bad way of doing things, okay? So in the history of probability, Laplace was the first person to realize that if you just approach probability with this way, and if some event doesn't happen so often, but it may happen, there's a difference between saying, oh, this occurs with 0 probability, and this occurs with 10 to the negative 1,000 or some 0.0001 probability, right? Yeah. So what's the, for example, what's the probability of a worldwide nuclear war? Well, it never happened before, right? So do we say it's 0? If you go by this, it'll be 0. But is that right? No, it's like some positive probability. We know the danger, right? It's like 0.00001, but it's there, right? So you don't want to just say this. And Laplace, this is called Laplace smoothing. He proposed the following. There's some kind of a coefficient alpha where you add top and bottom, and then you multiply this by some number k, where k is the number of different outcomes. And then, I mean, if you sit down and think for a while why this is so, it kind of makes sense, but for now, let's just accept that if you do this, then none of the probabilities will be 0. Okay? So, for example, let's say in the ham and spam emails, the vocabulary of all the words used was, say, 10,000 words. Okay? Then this number will be 10,000. Okay? And you're basically saying, you know, there could be a word that we haven't seen that even if you see 0 occurrence, okay, maybe it could be like 1 out of 10,000. So if you ignore this, this is like 1 out of k, right? Yeah. So there's like some probability that it should have. Okay, so that's like the very rough idea of this. So by doing this, we're going to avoid having 0 probabilities, because 0 probabilities are bad. Okay, so that's the plan. So now let me try to explain the code I'm going to write. I'm going to first load up the data in pandas, take the training, split it by training set and test set, and then once you have the training set, I'm going to look at all the words that appear and create a vocabulary. And then once we have the vocabulary created, we're going to count how many of the words in that vocabulary occur in the ham and spam. And then once we have them, then we can calculate individual probabilities by using this formula. Okay? And once you have that, then we can make a classifier where you throw in any email with some words in there. Then we start with log p of not s and all this, and you just keep adding, and then that's that's going to allow you to figure out what this is. And same way you can figure this out. If this is positive, that means this is bigger, so it's a ham. If this is negative, then this is bigger, so it's a spam. So that's the way we do things. Okay. Oh, yeah. One more thing is that this probability, the one without any x1, this one is like the default value of the probability. So we also need to know if you select a random email and you don't even open it, what's like the probability of that being a ham? Well, in our data set, about 70% is ham and 30% is spam. So this will be something close to 0.7. The other one will be 0.3. That's like your starting point. Okay? And then starting from there, initially when you don't see any words, that's your initial judgment. There's 70% chance that this is a ham. But then each of these words are going to change the probability so that eventually you get some kind of probability that you can compare. Okay, so that's the idea. Any questions? What I decided was there are definitely scikit-learn packages that does this for you, but we've been just using packages because a lot of the things that we've went over before is just too complicated to finish coding in 1 hour. Especially the linear regression and support vector machines behind the scenes, it has to do gradient descent, and that's not easy to explain or to implement in 1 hour. It takes a long time. But naive Bayes is simple enough that we can just use basic pandas and NumPy and just do everything in the most primitive level. So that's my goal today. We will even make the the recall and the precision values in F1. We're going to calculate those ourselves. Okay, we're not going to be using any scikit-learn packages today, right? Okay, so we're going to first import NumPy as NP and import pandas as PD. And shift enter, and usually I would also import the matplotlib for plotting, but we're not going to be plotting anything, so I'm not going to include that. All right. Okay, we will load the data set. So I know where my data set is, but I asked everyone to have it ready, right? So hopefully you have it ready. For me, this one is in C, users, Dan, downloads, and then emails.csv. The one that I sent out is a zip file, so if you haven't, please unzip the zip file. The data. You can see that there's the text and spam. If you want to know, and by the way, spam 1 means it's a spam. So let's see what the text is like. So df text, and then if I want to take the ilog the number 2, unbelievable new homes. Let's see what that is. There's something like this offer, something. Yeah, so I realize that if you see this word offer, it's likely a spam. But anyways, that's a spam. And something that looks a bit curious to me is that all of these are spam. Is that true? Let's look at the tail, df.tail. Oh, now it's none of these are spam. So apparently it seems like the data set that we have has spams in the beginning and then hams at the end. Now that's not good for training. We have to shuffle things. So let's try to shuffle. And there are several ways to shuffle. I just had to search online to figure out which is the best way to shuffle. So things like this you don't have to know. You just have to search online how people do it. So I just went to Google and searched how to shuffle data, pandas data frame. And they said the fastest way to do this, or the best way to do this, is to do something. So first, this DF sample with fraction 1 is like you're just resampling your original data frame one by one, which ends up being, because this is a sampling without replacement, if you do DF sample fraction 1, then see, your 1 is 100%, right? So you're basically sampling 100% of the data frame, which means you're just reshuffling your own data frame. That's what it's doing. Okay. The thing is, if you just do this, then the indices still, like they get shuffled, but the indices still follow. So we have to make sure that the indices are reset. So it starts from 0 again. And drop true is because if you don't have drop true, then the default is that the old indices become a new kind of column, and we don't need the old indices, so we're just going to drop it. Okay, so we're going to do this. Let's see what's in there. df2.head, and now you see that it's kind of mixed. I see one spam and the other being ham. Okay, df2.tail, it should also be mixed. Yeah, so I see some spam and ham mixed, which is good. All right, so that's exactly what I wanted. Now, we need to know the number of spam and number of ham. So number of ham is, we're going to do np.sum, or we can also do length. Length of df where the spam is equal to 0. Okay, if it's not a spam, we take that portion of the data frame and then just calculate the length. That's the number of ham emails. And we are also going to define number of spam emails the same way, length of df spam, and then if it's 1. Okay. And let's print them. Num ham num spam. And let's also print the sum. Num ham plus num spam. I think since the number ends at 5727, the number of emails that we have should add up to 5727. Okay, so let's enter, shift enter. Oh, what's happening? Oh, okay, so that's obviously not the one. Oh, sorry. I thought this is, so I have to select from the DF, right? Okay. So that's why it's important to print things. If you just don't print things, then you're going to find this out much later. It'll be very hard to actually. Okay. So, it's 5728 emails because the indices start from 0. Okay. So you see that 4360 divided by 5728 gives you 76.11%. So about 76% of the emails in this data set is ham, and the other 24% is spam. Now this is a very important reference point. So here's a question. If you just make a very dumb kind of a classifier, so let's say you're working as a consultant and there's this company paying you, say, give me $10,000 to make a spam classifier for their internal emails or something, okay? And you got lazy and the due date is like 30 minutes away, so you just make whatever. Just randomly say this is spam and that's ham, okay? 50-50%, okay? So you present that to the company, and they want to see the accuracy. Oh, this is only 50%. I'm just beginning. I'll be better. And they're going to say, oh, that's like really bad. Why? It's really bad because you could do better without making any dummy ones. Just make something that says, oh, this is ham, randomly 76%, and this is spam. Oh, no, not that, sorry. Just say it's ham, none of them is spam. Just say it's ham all the time, okay? If you do that, what's the accuracy of that one? It's going to be correct 76% of the time. Isn't that right? Right? You get my point? You can make a really dumb classifier where it says this is ham 70 for all the inputs, and it'll be right 76% of the time. It's better than 50% that you just made. Yeah. So that's your baseline. Okay. So whatever classifier you make, even if it's your first iteration, if it does work in any way, it better be better than 76%, because below that, that's like worse than just a dummy classifier. Okay? You get that? This is a very important concept. Okay? All right, so that's our goal. We need to make a spam filter that's better than 76%. Okay, let's continue. Now let's try to split this into training and test. So what I'm going to do is training is going to be equal to df2, the one that we shuffled. And because, let's see, the total is 5728, right? So we're going to do integer, because if it's not an integer, this complains, okay? So what we're going to do is we're going to take 5728 emails, 5728 emails, times, I'm going to use 80% for training set, okay? So we're going to use this number. So first, 4,000, I think, 4,000 something emails will be in the training set. And the next, whatever that's remaining will be in the test set. So df2, we're going to copy this number, and we're going to say, beginning this number and afterwards, we're going to make it as test. Now, the Python index system works in a way that when you have colon and some number, the actual indices stop at 1 before this number. So even if you see the same number here and there won't be any overlaps between training and test. Some different languages might have a different way of indexing, and in that case, there might be one email that's classified both as a training and test, which would be bad. But this is what we're going to do. Okay, so this is going to split the data set as 80% training and 20% test. Okay. Okay, so now let's look at training.columns, see what we have. It's very simple. It says text as spam. And we have to do some cleanup. What are some of the cleanups? Well, if you look at the previous output, we had like one output here. See, there are several things that really shouldn't be classified as a, it shouldn't be classified as a word, because like this dot or this dollar sign, we don't like them, okay? So we are going to delete those. And here is when this new concept comes in. When you clean up string data, there's something called regex. And I have this regex cheat sheet you can look. So what regex does, it's a convenient way to grab a character by the type. So for example, if you do /d, it will take all the numbers from any digit from 0 to 9 will be regarded as /d. So if you search /d, it's going to find all the numbers only. If you do /w, that's word character, meaning that it's ABCD or numbers, digits. It could also have underscore. And then small s will be any white space. There's also a capital big S, which is a non-white space character. And the one that we are going to use is backslash big W, because we want anything that is not an alphabet or a digit to be deleted. Okay, so this big W slash W is what we are going to find and delete. And the way we are going to do it is by doing the following. We're going to do training text equals to training text dot str dot replace. So pandas is a big package, so there's so many methods, and among them are these string methods, and you can replace them, and you can replace them anything by anything. You can just replace anything by anything, but what we are going to do is we are going to say all the white characters, all the non-word characters should be replaced by an empty space. That's what we're going to do. Okay, but Python doesn't know that this is non-word. You have to tell them that you're using this regex. So this regex is a not just Python thing. It's like most languages nowadays, like C++ or Java or whatever, JavaScript, they have this regex capability. You just have to search up somewhere for the package. So for us to tell Python that we're trying to use regex here, you have to say regex equals to capital true. Okay. Now, one small thing is that you need to put an R in front. That's anytime you have a backslash. Backslash means something inside a string. So if you want Python to actually think of backslash as backslash, you need a R in front. You may have noticed that I'm doing the same thing in the beginning here. I put an R in front of the string because if you're using Windows system, you always put an R because you have a lot of the backslashes when you go through folders. That's what I do. In Linux or Mac, they use /, so you don't have to put this R. It's just some quirky behavior of the Windows. I think Bill Gates wanted to be different from the Unix system, so they changed the / to backslash, and then we're stuck with having to use this R. Okay, so that's what we'll need to do. We will need to put an R just so that backslash is properly understood as backslash. Okay, so that's what we're going to do. If I execute this, all the non-word characters like the dot or $, stuff like that will be replaced by blank. And another thing is when you count things, you really don't want to respect the case. Whether it's uppercase or lowercase, you don't want that to be distinguished. And if you actually look at the data, it looks like they already did the lowercase, but just to make sure, let's do that. So what we are going to do is we're going to copy this much again, paste, Control V to paste.
We get an error when we run the first line.
Oh, really? Let me see. Oh, this is not an error. This is a warning. It does work. It's just that they have something. So I think the code that I was looking at was a bit old. Pandas frequently updates, and what they're doing is they want to make sure that people are not overriding stuff carelessly. So they have this other way of doing things, but it's okay. We'll just go by this. Okay. It will produce error every time I do this, but it's okay. Right? Okay, so I'm going to copy this much, paste it here, and I'll put lower. Okay, another thing that I found is that all these text has the subject. I need to delete that. So see, after this lower, subject will be lowercase subject. So I'm going to, and the colon is a non-word character, so that's also going to go away. So anytime I see the word subject, I'm just going to delete it. Okay, so I'm going to, again, paste and then replace. This time, anytime I see subject, I'm going to just delete it. This time, not even white space, just completely delete it. Okay, so that's what I'm going to do. Again, it's going to throw in some warning, but it's okay. Yeah. All right. I should have done this before splitting because I realize now that I should do that for the testing as well. Okay, so let's do that for the testing. So I am going to copy this again, but we're going to put, instead of training, I'm going to put test because we have to do this anyways later, but let's do it now. Test. So change both of them as that. And again, copy this much, paste, and lower. This makes everything lowercase. Paste and then replace subject with nothing. So that's replaced. Okay, Shift Enter. Again, Pandas is going to complain, but it's okay. It should work. Okay. So now let's see what we have done. So I'm going to pull up one of the texts. So training text, and I'm going to look at iLog, the 10th one. Let's see what's in there. Okay. Territory client. This looks more like a spam. Oh, this, yeah, it could be a spam, right? Okay. Yeah. Okay, good. Yeah, so business deals or something. It's probably a spam. Okay, so what I want to do is I want to show you the following. If I take this 10th one, and then if I do split, let's see what this does. What it does is it makes a list of words that appear in the email. See, every time there's a space, it's going to delete the space and get the previous one as a word, and it's going to store in this list. Okay? So this is convenient for us because now we can easily split a given email into a bunch of words. And then with this, now I'm going to build a vocabulary. So let's make a vocabulary list. Vocab would be an empty list. So list in Python, they use square brackets. And because I don't have anything in there, this is an empty list. And I'm just going to keep adding words from the text. So what I'm going to do is for email in training text. So I'm going through all the texts in the emails, and I'm going to look at all the words for word in email.split. So as I said, the split just splits the text into a bunch of words, and it creates a list. And this for loop goes through each of the words that appear. Okay, and then what I'm going to do is if the word is not in, so if not word in vocab already, if it's not one of the vocabulary words that you know already, then we're going to append it. So vocab.append word. Okay? Yes.
I'm sorry, could you scroll up one, this one? And those are just all like keywords, right?
What?
And are those just, I just want to make sure, are those all just like...
These are the words that appear in this email.
Okay, yeah.
So see, the real, time, project, all these appear in here. Okay? Is that okay? All right. Good? All right, so I'm going to Shift Enter. This is going to take a while because it's doing a big job. But I think it takes like 20 seconds, 30 seconds or something. Yeah, but while we wait for that to actually do its thing, let's look at the length of the vocab, see how large the vocabulary is. So we're going to yeah. So we're going to shift enter. It's not going to show anything before the previous one's executed. Oh, okay, it's done. All right, so 33,718 words. Woof, that's a lot, okay? That's why it's taking a long time. But then if you recall what our plan was for calculating probability, we need to know how many words are in spam and how many words are in the ham. So let me see. Okay. So now we're going to look at each of the words and then start building a dictionary of word counts. So let me quickly give you the idea of a dictionary. So see, if you have a list L equals to 1, 2, 3, or not 1, 2, 3, let's say Sam, ham, and spam. Okay, so what this is it's a list, and lists are accessed by square brackets, and you put numbers for indices. L0 would be the first element, so it gives you Sam. L2 would give you the third element, spam, so that's how it works. But then there's something called a dictionary, and the plan is to make a dictionary. So we're trying to build something like the word Sam appears, say, 10 times, and the word ham appears 20 times, and then the word spam appears 5 times or something, okay? Now, if you have a dictionary, then you can access the elements in the dictionary by using keys and values, okay? So if you have, if I want to know how many times does Sam appear, then it's going to say 10, right? And so on and so on, okay? So dictionaries are where instead of indices, you can put whatever, okay? Lists are, so the difference between lists and dictionaries is that for lists, you can only put numbers. You can't put letters for indices, okay? You can't put strings for indices. So that's the big difference. And there's also another package that we're going to make use of, which is something called a counter. So from collections, import counter. So collections is like a default Python package that has a lot of convenient things written for you. I said we're not going to be using packages, but this is like one package that we will end up using. Okay, so we have that, and then let me show you how this works. So suppose you have a word list where Sam appears twice, ham appears once, and then spam appears 3 times. Then if you do counter with L in there, then it's a very convenient one. It will tell you that spam appears 3 times and Sam appears twice and ham appears once. And if this says counter in front, but it works like a dictionary, okay? So if I say D is equal to counter L, and then if I ask what's D of Sam, it's going to give you 2. So it works like a dictionary, okay? All right, so knowing this, let's now continue going through all the emails that are ham and spam, and then just build this word count. Okay, so I'm going to start with the spam. So word count spam equals to, I'll start with an empty dictionary. And then we're going to make sure all the vocabulary words are present, because some of the vocabulary words might only appear in spam or ham, so we're going to make it initialize. So we're going to do for word in vocab, vocab append, no, not that, sorry. Word count spam. Oh, by the way, there's a tab completion. You can tab, it will complete. Word count spam, and then the word is set to 0 because you didn't read any emails yet, so all of the words are now reset to be 0. Shift enter. And then now we are going to go through all the words. So, I'm also going to have to count the number of spam words. So num spam words equal to 0. And now we're going to loop through all the training emails that are spams. Okay, so we're going to do for email in training spam equals to 1. Those are the spam ones, okay? And for those data sets, I'm going to read the text. Okay, so so email is going through all the texts in the spams, and then we're going to count all the words. Counted are counter. We apply counter to the email.split. Remember, splits all the emails into different words, and the counter just counts every word, how many times it appears, okay? And then, oh, sorry, that shouldn't have been, I shifted entered, sorry. Let me go back. Count it, and then what I do is, for word in counted, so for every word that appears in counted, what I'm going to do is word count spam, go through that dictionary element word, and add the counted word for that one. So, for example, if Sam appears twice, then counted Sam would be 2, and 2 will be added to word count spam of Sam. So if you do that and go through all the emails, then all the occurrence of Sam will be added up, right? So that's how this thing will work. You also need to count how many words. So num spam words that I made here, the default counter, num spam words, plus equals to one, plus equal to the same thing, so that I know the total number of words that appear in spam. I need this for calculating the probability, okay? So let's do shift enter. Oh, that was quick. All right, then I have to repeat this for the ham. So let's do this. Copy this down, place here, but then now it will be ham. And let's also copy this one as well. Place it below. Make sure you untab it. So it starts here. And then again, this will be ham. Email in spam. So this should be spam, but hams are the ones that have value of 0 for spam. And then word count ham, and number of ham words be like this. Okay? So now we shift enter. So that's done. And that's it. Now we can compute the probability. Let's do both of them at once. So remember the alpha value, we're going to set it as 1. And then in the previous one, I had k. K is the number of vocab words. Oh, I had that somewhere. Oh. Okay, so that's like, yeah, so this will be like the length of the vocab, okay?
Why errors when you run like the first word count?
Yeah.
Spam for word and vocab, word count spam word thing?
Uh-huh.
Errors.
I'm sorry, that's, I don't know that one, yeah. Yeah. There must be something with the bracket and curly braces, okay? All right, and then we're going to make another dictionary of probabilities. Okay, so probability of spam and probability of ham for each word. Okay, and the way we're going to do it is for each word in vocab, I'm going to calculate the probabilities. So let's do this. Probability of a word appearing in spam of a given word is, first you have to know word count spam of that word. So how many times does that word appear in the spam, okay? And then plus alpha. I'm using the same formula I wrote on the board. And then number of spam words that we counted. So that was, so this word, number of ham words is here, but we also have number of spam words. So that's going to be used, and then alpha times k. That's what we have as the formula. And for the probability of the ham, it's the same. So let's just copy this and just change the spam into ham. So spam, instead of spam, I put ham words. Okay? So that gives me the probability for any of the things. Okay. All right. So now we're going to make a classifier. So define classifier. And for a given text. So we're going to start with log probability of ham. That's the np.log. And we're going to use the 0.7611 that we found out before. Okay, so that's the default probability of being ham, right? And of course, I'm hard coding this, and that's not a good thing. But since lack of time, I'll just use this. But you can go up, way up, where we define this number and put that as a variable instead. Logarithm of the probability of any random text being a spam would be np.log of 1 minus 0.7611, whatever that is. Okay, so those will be our default value if we don't have any words to count on. Okay, and then we have for word in the given text.split. If word is in vocab, okay, then log probability of ham, and both log probability of ham and log probability of spam would be altered. Okay, so we're going to use np.log of probability of ham. We already calculated the probability of that word being in the ham, right? So we have that. And then you have log probability of spam plus equals to np.log probability of being in spam. Okay. And as I explained, if log probability ham minus log probability of spam is bigger than 0, what do we say? It's a ham, right? But because our definition of ham is when the value is 0, right? So we're going to say return 0 to say that it's a ham. Okay, else, what do? Return 1. Okay. Now there's this strange case when it's exactly equal to 0, then the classifier wouldn't do anything. But you know, that doesn't really happen much, so we're not going to care about that. So this is going to be our function. Okay, so you remember that the DF2, training, ILOC 10. You remember that text, right? What was that? It had something like that. And what's the value of Is it a spam or not? I think it's a spam, but let's see. Spam. Oh, it is a spam, right? So let's use our classifier to see if it's a spam. Okay, so I'm going to say classifier applied to training text, and then I'll pull that same data ilog10. Yes. So it does know that it's a spam, okay? So it's working. All right, now, but this is from the training set. Now we actually have to apply this function to the actual test set, okay? So let's now actually do the full matrix, you know, the TP, FN, false negative, false positive, true negative. I'm going to reset all of them as 0, so 0, 0, 0, 0, 0. That's a quick way to use a one-liner to just make everything to 0. And here's what I'm going to do. For index, row in test set, iter rows. So this is a strange way that pandas requires you to do. If you want to iterate over every row, you have to use this syntax. Okay, so you just have to know that. So, sorry, it's like I didn't make the pandas myself, so I'm not responsible, but it's a bit annoying. Yeah, but there are reasons why. Okay, so we'll say, is it spam? And we will look at the row that we just figured out and look at the spam. So this is the actual true value. If this value comes back as 1, then we know it's spam. If it comes out as 0, then we know it's not a spam. Okay, and then we will also say Bayes thinks, the Bayesian classifier thinks whether it's a spam or not. So we're going to say classifier of row of the text. So we're going to feed in the text to the classifier and see what it thinks. Okay, and then we're going to we have 4 cases, right? If is it spam equals to 1. So if it's an actual spam, and if Bayes thinks, tab completion is really nice if you use it here. So Bayes thinks equals to 1. If Bayes really does think that it's a spam, that's a true positive, right? So we're going to say true positive is added by 1. Okay. Else, that means it's an actual spam, but Bayes misclassified it as a ham. So which one should I increase? False negative. Okay, because it's classified as negative. Okay, it's false negative. Okay, and then going to here, else, if it's not a spam, and if Bayes thinks it's also not a spam, right? Then which one do we add? It's true negative. It figured out that it's not a spam correctly. And then else, we add the false positive. Okay? So we do this, and then we are going to print this thing upstairs. So I'm just going to copy that, place it here. Let's print it. Oh, it's taking some time, 30 seconds. But while we wait, let's also find the recall and all that. So what's recall? Do you remember? You're going to take a test on this. It's TP divided by TP plus FN. Oh, it gave, oh, that's nice. So, yeah. These two numbers are false ones. It's very small, right? Okay, precision is equal to true positive divided by true positive plus false positive. And then F1 score is 2 divided by 1 over recall plus 1 over precision. And also there's the accuracy. Accuracy is how many you got right out of total. So accuracy is TP plus TN. These are the ones that you got right. Divided by all the sum. TP plus FN plus FP plus TN. Okay, and then we're going to print recall, precision, F1
accuracy. Let's see what it says. Oh, those are beautiful. 99% accuracy, 98% recall score, and 97% precision. Okay, so that's amazing. That's much better than what I thought. Okay, that's all for today. Thank you.